Now, members, we are going to see a question which requires us to construct a flow chart that computes and prints the sum of the squares of the first 5 natural numbers. Perform a dry run on the constructed flow chart. Now, because I'm talking about a sum and then the natural number, I'm going to start by relating them. Let S be the sum and N be natural number. And then, if I have these no natural numbers, they always have a difference of 1, 1. So it means that now, N plus 1 next to natural number. The next natural number. Now, because I'm summing the squares, I'm going to say let my sum be defined by the sum plus now n squared. So the sum I'm going to get after the initial sum, I add the next n squared. I get the n, then I get the n squared. Now, here I'm going to define and n be n plus 1. Define the next n. So now, to construct this mathematically, this is wrong, of course. And now, I'm just using it as a counter. So now, I'm going to be with my first start stage, the start. Remember, I want the first 5 natural number. Now, the 50th natural number is 5. So now, I'm going to start with when I have no natural number. So let me call it when n. I'm going to say when n, we say this one, you construct it in a parallelogram or rectangle. So I'm starting when n is 0 and when the sum is also 0. I have nothing like a natural number. Even when I have no natural number, it means that even the sum is going to be 0. So from there, I'll come and say I'm going to say now my s is going to be equal to s then plus n squared. We are coming from here, we go to this, from there we come to this now, from there I come to the decision stage. There are many ways, but this is how I'm going to construct it. Now, I want the n until when I reach 5. So I ask myself, is n equaling to 5? That is the question. Is n equaling to 5? If yes, okay, let me start with no. If you have a no, if it's not equaling to 5, then this is a no. It means that we have not reached. Is n equal to 5? If no, we have not reached. It means that now, on the number used, you are going, on this number used, you are going to add a 1. Why are we adding 1? Because natural numbers are in the difference of 1, 1. From one next natural number to the next, we always add a 1. So now, my counter here is going to be now n. I'm going to say my counter now here. On the previous, if this wasn't giving us, which it wasn't a 5, it means that on that n, we are going to add now a 1. After adding a 1, you come back and reread it and get the sum again. Because the n is going to affect also the sum. You read it again like that. So you come there and you are processed again. If yes, if the answer is yes, if the answer is yes, we are very happy. We are going to say this. You can use a rectangle or you can use a parallelogram. Whatever I use, it's going to be okay. But in most cases, when this is parallelogram, even this is a parallelogram. Anyway, but let me do this, don't worry. So I'm going to say now, if it's yes, then print. We are going to print now n and also our s. But I'm interested in only the sum. that prints the sum of square numbers. So I'm not interested in that S. So now that's why I'm going to remove this N, because I need only the sum. This one should compute and print the sum. So that's it. Then after that, after I've printed my S, then here I have completed this task. So here, what I'm going to do is to stop the process and see that will be my flow chart there. Now after doing that flow chart, now they're telling us that perform a dry run on that constructed flow chart. So we have N, we also have our S. Here we have the decision, is N equaling 5? That is the question, is N equaling 5? Now, the didn't ask to start with 0, and also here we start with our 0. No. If no, add the 1 on this. We go back and now add the 1 on this end. When we add 1, we get 1. Then how do we get the sum? We get this plus 1 squared, we shall get 1, which is no, N is not 5. Then we add 1, we get 2. That is that if we know, go back and add the 1. If we add 1, we get this. How do we get this now? We shall get 1, the N plus, the S plus N squared, which will give us a 5. Is N equal to 5? The answer is no. If it's no, go back, come to 3, add 1. When I add 1, I get 3. Now this will be 5 plus 9 squared, which by 3 squared, this will give me a 14. And the answer is no. Add 1, we get 4. Then 14 plus 16. Remember when we square this, we get 16. Plus now the S, so if we square this, we get 16. Plus this, we shall get our 30. Is N5? No. Then we come to we add the 1, we get 5. Then when we square this, we get 25. Add on 30, we shall get 55. Is N5? The answer is yes. And you say if it's yes, now print S. Now we shall come here and we print our S. We print our S as 55. So that's what we get when we sum square. As you check yourself, you square this plus the square of 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 this. You start to get 55 because these are the natural numbers. But we are starting from 0 because if we have 0 as N, we are going to be adding even the sum as 0. So that's it, members. I wish you well. I think we have exhausted all the examples we supposed to handle. Now this one I'm taking it to be my encounter here. Okay, so that's it. Wish you well. But arrows should be important. So here I listed an arrow, here is an arrow, here, then this is also, so I think everything there is okay. So that's it, members. Wish you well. Now here, if the question may be and given you this, they will ask you, what is the relationship between S and N? Of course, you see that these ones are sum of squares of these numbers. When we square these ones, we get 55 after adding them. So that's it, members. Wish you well.